Now that we understand something about the metric system and the equalities within the metric system, and have given some thought to converting between things like the metric system and the US system, I want to give you a very specific guide, a way to tackle conversion problems that will ensure, and I promise this is going to be true if you follow this very specific plan, that you will always get the right answer. So what do we need to do? Well, let's say we have a sample problem here. We have an adorable beagle, and this adorable beagle weighs 45 pounds. Now, let's say someone asks you, well, I don't really understand the pound system. What does this dog weigh in kilograms? So we're going to put a question mark, and we're going to put kilograms. So this would be a step one. You're going to state the given quantity, which is 45 pounds, and you're going to also write down the needed quantity, which is kilograms. So then the next step would be, well, what's our pathway? Number two, how are we going to get from A to B? Or what is A to B? So that's going to be pounds to kilograms. That's our path, right? Very simple, but we have to get there. How are we going to get there? We're going to state the equalities and the conversion factors. So an equality here is going to be what, for example? It is going to be, in this case, it is going to be 1 kilogram equals 2.2 pounds. Okay, but that's not in conversion factor form. In order to put that in conversion factor form, we actually have two possibilities. One is to say that for every 1 kilogram, we can put it in a fractional form. We have 2.2 pounds. Not really fractional, it's a ratio. We could also say it the other way around, which would be to say that 2.2 pounds in every 1 kilogram. Depending which way we use this ratio is going to depend on whether we're going from pounds to kilograms or kilograms to pounds. Okay, and we'll see that in a minute because units have to cancel. All right, now we have completed step 3. We've stated the equalities and the conversion factors. So now we need to do something quite important. We need to set up the problem in order for the units to cancel, and this will give us our answer. So you can think of that in this way. Given quantity times the conversion factor, question being, which one of these do we need to use? Because we have two different possibilities. So given quantity times conversion factor gives us desired quantity. We can look at that in a way that's even more useful. Given unit times desired unit over given unit. What's that going to do for us? That's going to make sure that the given unit cancels and that we're left with the desired unit. Okay, so now let's just solve the puppy problem. And we're going to say 45 pounds. Oops, wait a minute. I'll erase that. 45 pounds times 1 kilogram per 2.2 pounds. So notice what's going on here. The 2.2 pounds is in the numerator. Pounds, therefore, are going to cancel. And that's exactly what we want because we want to be left with kilograms. This also means that we're going to have to divide 45 by 2.2 in order to get our answer. So that's going to be, I don't know precisely what, that's going to be something a little bit, let's say it's going to be approximately 20 pounds. You can do the math there yourself, that's not as important, but it's going to be, I said pounds and I didn't need to say that, it's going to be around 20 kilograms. And when you write the answer down, what are you going to do? You're not going to just write the number, you're going to write the unit. So you make sure you have it correct. Okay, so object lesson here is if all units cancel except for the desired unit, you have solved the problem correctly. So follow this plan. It's a little bit more work, I grant you, than just maybe trying to do a quick calculation in your head, but it is foolproof and you won't make mistakes. Now we're going to take a typical textbook problem, perhaps not a very exciting one, but it'll give us some practice. So a person's average daily intake of glucose, a form of sugar, is 0.0833 pounds. What is that mass in milligrams? Now notice we're doing a little bit something similar to what we just did with the beagle. We're going from pounds to a form of grams. What do I mean by a form of grams? Well, in this case, we're going from the pound to the milligram. So this, we're not going to pull it off in one step. Why? Because we're going to have to take a middle route. We're going to have to go from A to B to C. So what do I mean by that? Well, notice here we're given a conversion factor that is 1 pound equals 453.6 grams. Well, we can go from pounds to grams using that equality by simply turning it into a conversion factor and doing what we just did in the previous exercise. But we still need to get to milligrams. So how are we going to tackle that one? Well, let's follow our strategy, right? First thing to do is, what are we asked and what are we given? So this is our given, this is our asked. I would be tempted to write that the other way around, but however you do it, as long as you're keeping track, it's fine. And the second step is to write down our equalities and our conversion factors. Well, in step 1 here, we know that the relationship between pounds was given in the problem. So we could write down 1 pound equals 453.6 grams. However, we need a second conversion factor, right? We need to know the relationship between milligrams and grams. And it just so happens that 1 milligram equals 10 to the negative third gram. So that's our second equality and our second conversion factor. Now we tackle the problem in terms of the calculation. We set up, like we just saw, so that the units that we want to get rid of are going to cancel and the units that we want to convert into will remain behind. So let's take a look at that. So the plan, if you were to write down the plan, which I encourage you to do, would be to go from pounds to grams to milligrams. And we have these two conversion factors. Now, conveniently, in this solution, they have written it in such a way so that these conversion factors have the given unit in the denominator and the desired unit in the numerator. So notice that this is being solved even though it's a two-step problem in one step. And the more practice you have with conversion problems, the easier this will become for you. But let's actually break down what we're doing here. We know we want to get to milligrams. So we start from our given, and our first step is to multiply our pounds by grams per pound so that grams cancel and we get, pounds cancel and we get our answer in grams. Then we're going to take those grams and we're going to do a second thing. We're going to multiply whatever answer we got in grams by a second conversion factor, which is 1 milligram for every 10 to the negative third grams. And that's going to give us our answer. As pointed out, if we look at the whole problem here, the one-step problem, we notice that the pounds canceled, we notice that the grams canceled, and we're left with the milligrams, which is exactly what we want. I'd like to return us to this concept of converting volumes, which, as I mentioned previously, is going to require us to think in 3 dimensions. So let's take a look at this cube here. Notice that our cube has a volume of 10 centimeters times 10 centimeters times 10 centimeters. If we were to look at this in centimeters, that gives us 1,000 centimeters cubed. Now, another point here is 1 centimeter cubed equals 1 ml, which is illustrated right here by this little block. So we could use that to say that 1 centimeter cubed equals 1 milliliter cubed, and it follows that 1,000 centimeters cubed equals 1,000 milliliters cubed equals 1 liter. So this is all very well and good, but how do we use this if, let's say we had a box of a different size, and we wanted to convert from centimeters cubed to decimeters cubed. Okay, well, that's very doable. So let's think about what we're trying to do. We're trying to go from centimeters cubed to decimeters cubed. We need the equality here between the centimeter and the decimeter. So we're going to say 1 centimeter equals how many decimeters? 1 centimeter actually equals 10 to the negative 1 decimeter, or 1/10 of a decimeter. Another way to say that, as we've seen previously, would be to say that 1 decimeter equals 10 centimeters. We're going to go with this for the time being. So now, if we were to convert, we would have to cube both the number and the unit. What do I mean by that? I mean cube around the parentheses so that we cube not only the unit, but also the number associated with it. So this means that 1 centimeter cubed equals 10 to the negative 3rd decimeters cubed. Okay, now we can use that if, let's say, hypothetically, we have a cube that's smaller than the cube that we see here on the left. It's actually 27 centimeters cubed. And we want to put that in decimeters. Well, we have an equality, so we can use that as a conversion factor. And we're going to say that for every centimeter cubed, well, there are 10 to the negative 3rd decimeters cubed in every 1 centimeter cubed. So what's our answer here? Well, clearly we have 27 times 10 to the negative 3rd decimeters cubed. Why? Because our centimeters cubed canceled. And this is yet another way of saying 2.7 times 10 to the negative 2 decimeters cubed. And that's our answer. So object lesson here is don't forget to cube both the unit and the number when making these conversions. Let's look at a problem where we put that principle to work. We're told here that an average adult has 5.2 liters of blood. We want to know the volume in meters cubed. Well, we just saw that 1 liter equals 1,000 milliliters equals 1,000 centimeters cubed. What's that going to do for us? Well, if we use that as a conversion factor, we can go from liters to centimeters cubed. However, we still need something to help us get from centimeters cubed to meters cubed. And take a look at this. Tell me what's wrong with it. There's something gravely wrong with this. I forgot to make the exponent negative here because, in fact, 1 centimeter equals 10 to the negative 2 meters. And if we cube both sides in their entirety, we get 1 centimeter cubed equals 10 to the negative 2 meters cubed equals 10 to the negative 6 meters cubed. So try to avoid that mistake. Unfortunately, it can be kind of an easy one to make unless you're really paying close attention, but it's important to get that relationship correct. So now we're going to use all of these, both of these conversion factors in order to solve our problem. Now we're ready to solve. So we're going to start from our given, which is liters. And we're going to use our first conversion factor, which is 1,000 centimeters cubed per milliliter. Liters are going to cancel, and we're going to be left at this point with centimeters cubed. But now, since we're doing this in one step, we have a second conversion. And we're going to lose the centimeters cubed, so we can go into meters cubed. And that's going to give us our final answer, 5.2 times 10 to the negative third meters cubed, which I remind you is the volume of an average adult's blood. Instead of expressing it in liters, we now have it in meters cubed. We're now going to take a look at a slightly trickier problem. Let's suppose that we're taking a look at Serena Williams' serve. And her serve travels a rather spectacular 122 miles per hour. So our question is, how far will the tennis ball travel in meters per millisecond? So how far will this tennis ball go in the duration of 1 millisecond? So what's our given? Well, I think it's pretty clear that our given is 122 miles per hour. So now we have to ask ourselves, well, where do we want to go? Essentially, we want to go from miles per hour to meters per millisecond. That means we have to break this down mentally into two different things. We're going from miles to meters, and we're also going from hours to milliseconds. Now, it would be a very good idea if you were doing this problem to write down all the conversion factors. I'm going to take a little bit of a shortcut here, and you can see from this one-step conversion process what the various conversion factors are. One thing I want to point out, which I think is very important, is you need to write this down, not as 122 mph, but you need to put miles clearly in your numerator and hours clearly in your denominator. That will help you make sure that units cancel appropriately. So the first thing we're going to do is we're going to go from miles to kilometers, because we know how to do that. We have an equality for that. 1 kilometer per 0.621 miles. And notice here that miles are going to cancel, and we're going to end up, at this stage of the game, we're going to end up in, you can think of this as kilometers per hour. However, we need meters. So our next step is going to be, well, how many meters are there in a kilometer? So we can cancel our kilometers, and there are 10 to the third meters in 1 kilometer. So at this stage of the problem, if we were to stop here, our answer would be meters per hour. But we want meters per millisecond, right? Notice hours are in the denominator in our given, so we're going to have to put hours on top for our conversion factor. And hours will cancel, and we'll be left with seconds here. Now it just so happens there's 3,600 seconds in 1 hour. We stopped at this stage of the game. Well, you tell me. I think we would have meters per second. We have one more step to go. We want to get from seconds to milliseconds. So if we say that there are 10 to the third milliseconds in every 1 second, this is going to leave us with our final answer, which is going to be 0.021 meters per millisecond. Now, since the question asked us, well, how far will the tennis ball travel? Technically, our answer should be 0.021 meters. And you can see that that would be true because this is per an individual millisecond. We could play around with this. What if we wanted to know how far the tennis ball traveled in 399 milliseconds? You should have some fun, actually, with coming up with your own problems and seeing if you can solve them. Pick a subject that you like, something that you're interested in, and design your own problem. It actually can be more fun than just, going to a chemistry book. You are only limited by your own imagination. The other thing I want to point out, since I'm very gung-ho about women in sports and women in general, is that if you look at this link here, it is actually a fairly common thing that women can serve as fast as men. And it has a lot to do with the physics of the whole thing. I think this link is really interesting. And if you're interested to know about tennis serves and women versus men and, serves in general, I think it's a great article. So take a look if you have some interest in that.